Hello, ladies and gentlemen. We're going to do 7-6A. We're going to solve exponential and log equations. We're going to do that by using our properties of logs and then our conversions between the two forms, both log and exponent, and then we're going to solve our equations. All right. Sorry, before we get started, I have some hints for you. So I'm just going to write those down, okay, as we work through this process. When you're working with exponential equations, okay, to be able to solve, oops, spelled it wrong, sorry, scribble, scribble, to be able to solve the baby equations at the top, the bases have to be the same. And so remember, we've done some work with moving fractions around with negative exponents. So anytime that you're working with exponential equations, your bases do have to be the same. Okay? You can use properties of logs to simplify an expression. And then you could use other methods after that. Sorry. You can convert back to exponent form. Okay. All right, so that's something that I tend to use quite frequently. You could use your change of base formula. Or you could take the log of both sides. And remember, you could do the natural log. It doesn't matter which log you use, as long as you're consistent. Take the log of both sides. Sorry, I'm really hoarse this morning. All right, so the best way for me to show you how to do this is just by doing lots of examples. And drink some more coffee. All right, so for our first example, they're all going to say solve. Okay, so I'm going to have 4 to the x is equal to 1/2 to the x minus 3. So this is an exponent form. So to be able to solve, I want to make the bases be the same. The base is going to be 2 because 4 to a power doesn't give me a 2. Actually, it does, but 2 to a power gives me 4. So I'm going to rewrite the left-hand side as 2 squared raised to the x. Sorry. I'm going to move this 2 to the top by raising it to a -1, and then I have x minus 3. Okay? A power to a power is multiply, so I get 2 to the 2x is equal to 2 to the -x plus 3. I distributed that -1. Now my bases are the same. I can solve the baby equation at the top, so I get 2x is equal to a -x plus 3. Add x to both sides, so 2x plus x is 3, 3x is 3. Divide both sides by 3, and I get x is equal to 1. Okay, so there's, oops, sorry, you can't see that. There's my first example, alrighty. Okay, let's do another example, and I'm going to switch colors of pens. Hopefully it's easy enough to see, so we're on different sides of the page. Alright, again, this one says solve. They all say solve. Okay, I'm going to have 9 to the 2x is equal to 27 to the x minus 1. This one's in exponent form. 3 squared is 9 and 3 cubed is 27. So I'm going to make the bases be the same. So I'm going to do 3 squared raised to the 2x is equal to 3 to the 3rd raised to the x minus 1. Remember, if I have a power to a power, I multiply. So I'm going to get 3 to the 4x is equal to 3 to the 3x minus 3. I distributed the 3. The bases are the same. I can solve that baby equation at the top. And I think the pink pen's a little hard to see. So I'm going to do 4x is equal to 3x minus 3. Subtract 3x from both sides. So I get 3x is equal to a -3. 1x equals a -3, so x is a negative 3. Okay, and there's that one. All right, so let's do another example. Okay, because that's kind of all I'm going to do today are just lots of examples. All right. Okay, again we're going to solve. And this one says 100 raised to the 7x plus 1 is equal to 1,000 raised to the 3x minus 2. Again, this is an exponent form. I can get 100 by doing 10 to the second, and I can get 1,000 by doing 10 cubed. So I'm going to keep them in exponent form. So I'm going to do 10 to the second times the 7x plus 1, and then 10 to the third raised to the 3x minus 2. Power to a power is multiply, so I'm going to get 10 to the 14x plus 2 is equal to 10 to the 9x minus 6. Bases are the same. Solve the baby equation at the top. So I'm going to get 14x plus 2 is equal to 9x minus 6. Subtract 9 from both sides and subtract 2 from both sides. So I'll do it both in one step. So I'm going to get 14x minus 9x is a negative 6 minus 2. Combine like terms. 5x is equal to a negative 8. So x is going to equal a negative 8 divided by 5. So that was pretty easy. Okay. Alrighty. Now let's do a different type of example, and I'm just going to stick with the black. I think the pink is really hard to see. Okay. Alright, this one again says solve. And I'm going to have 4 to the x is equal to 11. I can't make the bases be the same because 4 and 11 are not going to work. So I'm going to show you a couple of different methods. The first one that I'm going to do is take the log of both sides. There's actually a couple of different ways I can do this, and I'll show you both ways. So the first way, I'm going to take the log of both sides, because I can do anything to an equation as long as I do it to both sides of the equation. And I'm going to do the log of 4 to the x is equal to the log of 11. So I took the log of both sides. Now I use my properties. The exponent goes out front, so I'm going to get x log 4 is equal to the log of 11. I'm still trying to solve for x, so I'm going to divide this side by the log of 4, and I'm going to divide this side by the log of 4. And I'm going to get x is equal to the log of 11 divided by the log of 4. Now it's a calculator exercise, and I get 1.730, and that's going to equal x. Okay, remember we always identify our answers. Now let me show you the other way. Okay, so the problem started, and I'll write it here so you can see it. 4x is equal to the 11. It started in exponent form, so what if I converted it to log form? So I would do the log base 4 of 11 equals x. Okay, I can't do this in my calculator because it's a base 4, but I could do the change of base formula. So I could do x is equal to the log of 11 divided by the log of 4. And notice I got the same thing regardless which way I did it. So it's kind of a personal preference on how you do it. I tend to do one way and one the other, so it just depends on what pops into my brain first. But there you go. So it's the same answer doing it two different ways. All right. Our next example, I'll scoot back over a little bit. Again, it's going to say solve. Okay. And if I have 7 to the 9x is equal to 15, this time I'm going to take the natural log of both sides. Okay, so I'm going to do the natural log of 7 raised to the 9x is equal to the natural log of 15. Remember, it does not matter which log you use as long as you use the same log on both sides. Exponent property pulls that guy out front, so 9x natural log 7 is the natural log of 15. So now I'm still trying to solve for x, so I'm going to divide both sides by 9 natural log 7 and 9 natural log 7. So I'm going to get x is equal to the natural log of 15 divided by 9 natural log 7. Be careful when you enter this in your calculator. Parentheses are really helpful. And I'm going to get 0.155 for x. And there you go. All right. Now I'm going to come over here. There's one little property that we have to see. It's called the one-to-one property. And it's different than when we talked about one-to-one earlier in the year. So the one-to-one property says if you have a situation where you have the log base b of x is equal to the log base b of y. Notice that the bases are the same and the base that I'm using the common log instead of the natural log is also the same. Then I know that x equals y. Okay, so that's called the one-to-one property. So let's see an example using our one-to-one property. Okay. All right. So it's going to say solve, just like all of the others today. So I'm going to have the log base 5 of 4x minus 7 is equal to the log base 5 of x plus 5. Notice that I use the same log. The bases are the same. So what this means then is 4x minus 7 is equal to x plus 5. Okay? So that's using that one-to-one property. Subtract and add. So I'm going to get 4x minus x is equal to 5 plus 7. So I get 3x is equal to 12. And then x is 12 divided by 3, which is 4. Okay? All right. So there's our solution, and we used the one-to-one property on that one. All right. For the next example, just lots of examples today, I'm going to have directions that say solve. Go figure. So I'm going to have the log base 4 of 5x minus 1 is equal to 3. Because this one is in log form, I can't take the log of both sides, but I could go back to exponent form. So if I take this and convert it back to exponent form, I would say 4 to the third is equal to 5x minus 1. And the goal is to solve for x. 4 to the third is 64, so I get 64 is equal to 5x minus 1. 64 plus 1 is 5x. So 5x equals 65, and x is going to equal 65 divided by 5, which is 13. So there's my solution for x. So sometimes I am going to go from exponent form to log form, and other times I'm going to go from log form to exponent form. All right, I'm going to do your next example over here. Okay. Again, it says solve. Such a novel concept. So I'm going to have the log of 2x plus the log of x minus 5 is equal to 2. Okay? So now I'm going to use the properties of logs to combine these two statements. Remember that plus means multiply. So I'm going to have the log of 2x times x minus 5 is equal to 2. Well, remember, this is a common log, so even though it's not written, the base is 10. So now I'm going to go back to exponent form. So I'm going to say 10 to the second is equal to 2x times x minus 5. So I'm going to get 100 is equal to 2x squared minus 10x. So I distributed. This is a second degree polynomial. It's a quadratic, so I need everything on the same side to solve. So I'm going to get 2x squared minus 10x minus 100 is equal to 0. And I just put everything on the left because I like my variables on the left. I'm going to divide by 2. And so I can divide this side by 2 and this side by 2. And I get x squared minus 5x minus 50 is equal to 0. Okay? All right, the factors of 50 that add or subtract to give you 5 are 10 and 5. So this is going to be x minus 10, x plus 5 equals 0. So then I'm going to get x is equal to 10 and a negative 5. But this solution presents a little bit of a problem. So let's go back and talk about the graph of logs for just a sec. The graph of logs of y equals to the log of x goes this way, remember? And this would be 1, 0. And remember we talked about the graph of a logarithm is undefined past 0. You can't take the log of a negative number. Therefore, that guy is extraneous, E-O-U-S. So x is equal to 10 is my only solution. So when we're doing logarithmic equations, you need to remember that you can't take the log of a negative number. And the reason why is because of the graph. All right, so let's start our next example. Lots of examples today. So this one says solve. I'm going to have the natural log of 7x minus 4 is equal to the natural log of 2x plus 11. We'll notice that my bases are the same, e on both sides, and I'm doing the natural log, so by the one-to-one property, I can say 7x minus 4 is equal to 2x plus 11. Now I can solve that simple equation. So 7x minus 2x is equal to 11 plus 4. 5x is 15. X is 15 divided by 5, which is 3. Okay, so there's my solution to that one. Alrighty. All right, I have one more example for you, and then we'll get to our problems. So pretty short lecture today, which is nice. All right, last problem that says solve. Okay, I'm going to have the log base 4 of x plus 12 plus the log base 4 of x is equal to 3. So in this one, the bases are the same, so I'm going to use my properties of logarithms to manage this side and condense it. So it's going to become the log base 4 of x, that's an x, sorry, plus 12 times x is equal to 3. Okay, and I'm not going to expand this yet, I will. So now I'm going to go back to exponent form, so I'm going to say 4 to the third is equal to x plus 12 times x, which is equal to x squared plus 12x. Notice that this is a second degree polynomial. It's a quadratic, so I need to take 4 to the third to the other side. Okay, so I'm going to get 0 equals x squared plus 12x minus 4 to the third, and 4 to the third is a negative 64. Okay. All right, 64 factors to be 16 and 4 to give me 12. So now I'm going to come up here. So I'm going to factor my expression to be x plus 16 and x minus 4 equals 0. So I get x is equal to 4 and a negative 16. But remember, just from our previous example, I can't take the log of a negative number because it's undefined. So the negative 16 is extraneous. EXT, weird word. And the only solution is going to be x is equal to 4. All right, so those are your problems for the, or sorry, those are your examples for the day. Now let me give you your problems, okay? All righty. And we're actually going to do a couple of days on this just to give us lots of practice with these. They all say solve. Huh, novel concept. Number 1, I'm going to have 7 to the 3x plus 4 is equal to 49 to the 2x plus 1. Problem number 2, 3 to the 3x minus 7 is going to equal 81 to the 12 minus 3x. The base on this one, by the way, is both 3. The third problem, I'm going to have 7 to the 6x is equal to 12. Okay. The fourth one, I'm going to have the log base 5 of 5x plus 9 is equal to the log base 5 of 6x. Okay. And I'm giving you examples from all the different types of equations that we did. The fifth one, the log base 2 of x minus 4 is equal to 6. And the last problem, okay, so a few problems today, but lots of different types of equations. So I'm going to get the log base 6 of 3x plus the log base 6 of x minus 1 is equal to 3. So those are your 6 problems. They're not very long, and some of them turn out to be very nice and polite. So good luck with your problems, and I will see you tomorrow.